Hey, good morning, you guys. It's George from the Northford Timber Framers here, doing a YouTube video this morning on changing the knives in a thickness planer. And so this is the thickness planer that I have in my shop here in Northford, Connecticut. And as you guys can see, it's a Newman, which over the years we've pretended there was a little hyphen there, so it's a new man is what it is. And this was made in Greensboro, North Carolina. And I actually know a bit of history about this machine. It came from Advanced Pattern Making in Bridgeport, Connecticut. It sat in an empty building for about 10 years with water leaking on it. It was totally rusted when I purchased it. There was orange spray paint all over the table where somebody had tried to protect it. We dismantled the machine completely, absolutely completely. Took every nut and bolt off, took the cutter head off, put new bearings in it, sent the motor out to a motor shop. We spent hours and hours and hours sanding and polishing and buffing the table surface. And so you see the fruits of our labor. We restored this machine, let me think about this, 15 years ago. We restored this machine in the summer of 2004. And it's been a mainstay in our shop ever since then. So some of the features that are really impressive about this Newman thickness planer, which my opinion is the nicest thickness planer in the world, the nicest thickness planer we could still purchase from anybody, or is anything close made to this. First of all, its in-feed and out-feed table are much longer than even the Oliver, which Oliver, as we know, is wonderful equipment. It has a 48-inch table surface, which if you're a one-man shop or a small shop, means you can get a board in, have plenty of time to go around and take it out yourself. So that's one of the features it has. Another very important feature that it has is you can actually vary the speed of the feed rollers. That's what I meant to say. And it's very easy to adjust it. And what I suggest is, what I learned in the pattern shop back in the 70s, is that you shouldn't force the wood. So more or less you should keep the in-feed and out-feed rollers as slow as they'll go. If you are building pallets or working in a sawmill and you're blasting wood through it, it's fine to go faster. But if you're really concerned with the finish that you're getting on your wood, such as you would be for timber frame braces or kitchen cabinets or 18th century furniture reproductions, which we do a lot of, you're going to want to keep the speed on that in-feed and out-feed roller as slow as it'll go. So another one of its features are that the top rollers are, of course, automatic. These are the segmented rollers, which are mounted on rubber. As you can see, that they give a little bit. And then this is the chip breaker here, which allows the chips to break up and get deflected into the dust collector. And you can see that they're spring-loaded. That allows the wood that's irregular shaped to sort of have these rollers hug the surface of that as it pushes and pulls the wood through. Now what's remarkable about this is that the bed rollers are also power rollers. So you have power upper rollers and you have power bed feed rollers. That's unheard of. The Oliver, as far as I know, there's not another thickness planer that has lower powered bed feed rollers. Maybe I'm wrong. Drop me a message if you have a thickness planer that has lower powered rollers. Now the other part of this that's amazing is that you're able to adjust the lower feed rollers with this lever right here. So you actually can lower the feed rollers or raise the feed roller just at the touch of your finger. So if you were, for instance, planing some tiger maple, you'd want to start with the feed rollers raised up a little bit. Let's just say around a 64th to a 32nd raised above the finished surface. After you established your correct thickness of your board, you would then want to lower those rollers so you had a very clean finish on the finished pass, so you wouldn't have any marks from these segmented rollers, and also you would have zero snipe. What we were just talking about a moment ago with raising and lowering those powered bed feed rollers is crucial to being a pattern maker, crucial to being a cabinet maker, because it really dresses the wood beautiful. With, as long as you have the rollers set up correctly, it dresses your wood out to where you have hardly any sanding and zero snipe, which any woodworker would know that sometimes, you know, we're a little disappointed with the snipe that we get in the end of a beautiful piece of hardwood like cherry or maple. Sometimes we're making a mark at the end after we've thickness planed it. But with those adjustable lower feed rollers, you can eliminate that. So I thought we would round this video out with talking a little bit about changing the knives in the cutter head, which it's a 4-knife cutter head. You guys have heard me talk in some of the previous videos we've done about the equipment in my shop about these frequency inverters that are available. This is a piece of 3-phase equipment. The cutter head on this is actually 7.5 horsepower, 3-phase. There's a second motor which is down underneath the machine which powers the feed rollers. Newman designed this so that the cutter head was, this upper motor is responsible for direct drive of the cutter head, so there's never a variation in the current as you're planing and putting this thing to work. So you have a true, consistent cutter head speed and torque. And the lower motor is responsible for the power feed rollers also, so you have a consistent speed that you're able to drive the wood through the thickness planer. Now, years ago, before the advent of these frequency inverters, I would not be able to run this in my shop, which is in my backyard on household current. Which, how many small woodworking shops are there in the USA where guys are building boats, building cabinets, timber framing in their shop at night after their real job? Well, you know, that's what I did for most of my real work career, was to moonlight and have a second nighttime job, which was cabinet making, furniture making, and specifically timber framing also. So when you see a piece of 3-phase equipment that you think you could use in your shop, whether it's a bandsaw or table saw, a jointer, or this 3-phase wonderful Newman thickness planer, don't shy away from it anymore. The frequency inverter is located down below inside the machine. It's 10 horsepower, so it has the capacity to power the 7.5 drive motor for the cutter head and the 3 horsepower motor for the infeed and outfeed rollers. So it's a 10 horse frequency inverter. Probably cost me someplace around $800. It's worth the money. It allows you to run a machine like this off your small shop electrical system. So I learned to do this in the pattern shop back in the mid-70s, and I thought I would share this knowledge that I have and show you the way that I change my knives in a thickness planer. So for starters, I would tell you that because it has four knives in it, what I've done is I've marked each knife. So 1, 2, 3, 4. And so the reason that is important is, and it's pretty cool because you can follow through the four knives as they're marked through 4 changes, and you can see where I checked with the dial indicator at the dead center, the outside edge, which would be 24 inches from here to here, and then in between. So you sort of take a picture with your dial indicator, and if we look at specifically this change of knives, you can see that knife 1 is protruding out from the head 60 thousandths across the whole cutter head. So in other words, it came out perfect. Knife 2, as I read this sideways, also came out perfect. Knife 3 was protruding 2 thousandths more here, 1 thousandth there, 1 thousandth less there. Knife 4 was under by 1 thousandth in one place. And if you follow this down, you can come up with the scenario where the knives are never out any more than a maximum of 2 or 3 thousandths. And in the pattern shop, our rule of thumb was the thickness of a piece of paper was 3 thousandths. So the first part of the lesson is, if you're getting your knives in a planer like this, 24 inches, 4 knives, if you're getting all those knives relative to each other within 2 or 3 thousandths, you hit a grand slam. That's as good as it gets, you guys. Now, that's why it pays to write down what you're doing when you change the knives. Now, if you had a 3-knife cutter head, you'd do the same thing. If you had a 12-inch wide cutter head, you'd do the same thing. Take a picture, in other words, check and write down, that's what I mean by take a picture, check at either end and the center, and then check all 3 of your knives. Now you have a history or a record of what you did the time before that. The other part of the lesson that I would start with is that you're only supposed to remove 1 knife at a time. So I'm not going to take out all 4 knives and then start to put them back in one at a time. The proper way to do it is to take out one of the knives. So specifically we take out knife 1. Then we install the next knife. Now, I learned in the pattern shop years ago that protrusion from the cutter head should be around 60 thousandths. Now, what you're hopefully able to see here as we look at it, although the cutter head may be out 60 thousandths, as you can see, the low side of the angle, as it's relative to the cutter head, is actually out of the cutter head approximately, I would say 3/16. So you don't want that to stick out any further. Now, the angle that your knife is ground at should be something that your machine shop or where you're taking them is consistent of. But the actual apex, the cutting surface, is out 60 thousandths. Now, here's what I use, you guys. I use this dial indicator, which is built in like a horseshoe fashion. So it has these legs which are adjustable, so you're able to set it on a flat surface. Then you're able to set the dial indicator relative to what would be the height of those knives. You can see that moves as the actuator is moved down below. It causes the dial to move above and lets you know what the protrusion of whatever you're measuring is in thousandths. So specifically, this was made for a thickness planer. Now the diameter of this cutter head here is around 4.5 inches, possibly 4¼ inches. I'm saying that by eye. It's around 4 or 4¼ inches. So the radius of that wants to fit in here on this homemade dial indicator knife setting gauge. So we would have removed this knife number 1. And then there are 3 screw actuated stops, if you will. So they're little cradles that the knife sits on. And obviously, to turn this screw counterclockwise would allow the knife to go lower. To turn these 3 screws at any one point clockwise would raise the knife. So let's imagine that we'd loosened knife 1 and we had removed knife 1. We would be putting in a sharp knife back in. Next, our job is to dial indicate that knife in to a 60 thousandths protrusion to the actual cutter head, the apex, the tip of that knife sharpened. So what I will generally do is snug up these gib screws relative to the knife sitting on these adjustable stops. Okay, if you can picture that in your mind, the knife is sitting in there on those stops. You want to snug these gib screws. Snug them very lightly, very, very lightly. And what I would do is, to start, I would just snug the end two and the center two. I would let these 3 interior ones, I would let those stay loose. While it was set in there with them snug, I would take my initial reading using the dial indicator gauge. By actuating the head on this by hand, I can actually see that the dial indicator moves. So I would dial indicate in the right side, then I would dial indicate in the left side, and then I would dial indicate in the center. And let's see if we can show you that. Can you guys see that that dial indicator is coming around each time and it's stopping at 40 thousandths? That's because the needle goes 20 thousandths the other way past 0. All dial indicators are different. So by this coming over and just kissing 40 thousandths, that's actually my 60 thousandths knife protrusion. Now let's check the center here. If I check between the end and the center, you'll see that it also is coming in and kissing 40 thousandths. Let's look at my most recent one. Down here, I have the far left side protruding 2 thousandths more than the rest of the knife. Remember, 2 thousandths is less than the thickness of a piece of paper. And if you take a survey, you can see that this right side seems to come in like that all the time. See how it doesn't quite come in perfect? So I have 62, 60, 63, and 59. Now you can do this until you turn blue. And I wouldn't suggest that you do that, because if you're keeping your knives to the tolerance that I've given you, that's that they're not out more than 3 thousandths in any one place, you're going to be very pleased with the job that's done. Okay, so you would just do the same process to the other 3 knives, and basically you'd be done. And you know, just for the heck of it, you guys, let's spin around to knife number 3, just because we can. And once again, I'm actuating the head by hand, and I'm holding the dial indicator. And as you can see, it's coming down. Hopefully you're able to view that dial indicator. And look at that. It's coming down and kissing 40 thousandths. But remember, the needle goes 20 thousandths past 0. So it's proving that knife number 3 in the center is set at 60 thousandths. And if we look at the records I took, we can see that it was. So keeping a record of each time you change the knives, you don't have to do it every time, but give yourself some history. And then it allows you to teach somebody who works in the shop with you, so you can teach someone else how to set the knives in your thickness planer, because now you establish a process. Right, you guys? Isn't that what's important? The way we change our oil in our pickup trucks, the way we change the oil in our motorcycle, however, whatever someone who's in the U.S. Navy is trained for in their job, they share that responsibility with somebody else. My only point is to create a procedure for yourself for changing your knives. Create a process that shows intelligence and some intellect. Create a process that you're able to teach or train someone else in your shop. So I'm thinking that's about it for this Newman thickness planer. And just a quick tutorial, you guys. So what I think we might do is at a future date, we'll go through setting up the thickness planer and setting up the in-feed rollers and the bed feed rollers. Because of course, the two important things that make the thickness planer function properly are, number one, the planer knives being set almost as perfect as they can get with a 60,000th protrusion from the cutter head. Number two is that the in-feed and the out-feed rollers have to be set with just the right amount of pinch, which would be pressure on the board. It needs to be set up so that it pulls the board out of your hand and so that you're not pushing the board as it goes through. If we take 1 second to look behind us over here, we'll see the dust chute. So I have removed this dust chute from the thickness planer just so we could show off the cutter head. But this will get reinstalled. Now I had this made by a local sheet metal shop, and I have it to a medium-sized industrial dust collector. And as long as I only make a cut under 3/16, I never get chips on the floor. It does a really good job. So I've got it hooked to a dust collector, which I'll turn the dust collector on now. Sorry for the noise, you guys, but that was a dust collector. And now I'll just give you a little look at what it sounds like when it's running. Cutter head is coming up to speed. With the frequency inverter, you can see the power rollers. Just as smooth as smooth can be, you guys. So there it is, you guys, changing the knives in a Newman thickness planer, and how to do it in an intellectual way, just as many pattern makers did, and lots of pattern makers' apprentices learned to do. And I would like to encourage you guys to consider taking the Northford Timber Frame class of 2019, which is coming up this April. It's on our website. I believe the first day of class is Friday, April 12th. We have an amazing project that we're doing this year, actually a very large timber frame. It's 32 foot wide and 68 foot long, and of all places we're going to be building this timber frame in New Jersey. So come to class in Connecticut, learn how to do it, come back in September and help us raise this gorgeous timber frame barn in blueberry country. And we hope to see you at timber frame class, and hey, we'll see you around on YouTube. Thank you so much.